I've started recording. Okay, so f of x is negative x minus 1, the quantity cubed, minus 1. Okay. Okay, so now the question says, starting the graph of a basic function, graph the following function using the techniques of shifting, compressing, stretching, and or reflecting. Find the domain and range of the function. Okay, first of all, uh, I guess shifting and stretching and all that is from 2.5. So we don't really need that, although I'll solve it because you have a quiz on Monday just before the class. I'll definitely solve it, but for the test you don't really need that. I didn't really mention that in the uh, email because of course for the quiz you need this, and it's good to know that because then you can clearly or easily calculate the domain and range as well. Okay, so shifting and stretching will not be there, yeah, but of course domain and range will be, of course, in the test. So that's why I didn't really say that avoid this. I want you guys to know these stuffs. Okay, yeah, definitely it will be on Monday. And if you can graph it using the concept of shifting and stretching and all that, it actually gives you lots of freedom to understand the domain and range. You know, if you have a graph, it's a lot easier to find the domain and range than calculating or than uh, imagining, right? You can actually visualize this. Okay, so first of all, we'll actually graph this before going for the domain or range. Okay, I'll actually show both ways. You can actually calculate the domain and range without even graphing it. I'll show that as well. But first of all, we'll graph it. So let's start. Okay, so that's our axis. So this -1, what does this -1 mean? Anyone? Down by 1. Yeah, exactly. Okay, and what does this -1 mean? Goes to right, exactly. Very good. So now if we just know how does the graph of, how does the graph of y equals x cubed looks like, then the rest is very simple. And if you remember, if you don't remember, don't worry, you'll have still Saturday and Sunday to go over this. But the graph of x cubed looks like this. Okay. Now, if you just multiply a function by minus, it actually gives you the mirror image. So graph of y equals negative x cubed will be actually exactly opposite to that. It will look like this. Whenever you multiply a function by negative, it will actually change its gear like a mirror image. Okay, so that's what a negative x cubed looks like. Now we know we'll go down by 1 unit and we'll go to our right by 1 unit. Okay, so previously, let me have the graph for you. So initially, we had to go like this at 0. Oops, at 0, it would have gone like this. But now we want to go to our right. So instead of 0, we'll actually change our direction at this point. This is our 1. And again, instead of 0, we'll actually go down 1 here as well. So that means 1 here, 1 here. We'll actually do it here, right? That's where the point 1, 1, 1, -1 rather, because we are changing our position by this. So let me erase this. Yeah. So now our new graph will look like this. Oops, sorry. Let me use a separate. Okay, that's it. Instead of 0, it actually goes like this. Or I didn't draw this properly, to be honest. Yeah, it should something look. It should look like this. If you draw this precisely, no, you don't need to uh, use this coordinate. What I meant with this is you are actually going to the right and moving one unit down as well. You are actually looking for this point instead of 0, 0. Okay, initially you are here at 0, 0, but now you will actually do it here at 1, negative 1. But you don't need to do that. You don't need to write that. If you can imagine how does this go to your go 1 unit downward and go to your right by 1 unit, that's okay. So that's your graph. Now by graphing, we have actually opened the way of getting our domain and range quite easily. So as far as I can see, for all the x's, the function is defined. So the domain looks like negative infinity to infinity. And of course, for all the y's, we have defined value as well, right? Because this graph is going everywhere, up to infinity, up to negative infinity. So that's our domain. So the range would be also negative infinity to infinity. Now, what if you don't have the graph? Again, you will actually go back to the main equation. Let me write it for you. F of x negative x minus 1, the quantity cubed minus 1. So the domain is the values of x, which keeps your function defined. And this is a polynomial. So clearly, you can always say that negative infinity to infinity is your domain. And for y, we have defined values everywhere as well. There is no value of y where it's not defined. So also it's negative infinity to infinity. Okay, but as you can see, graph gives us a better visualization rather. Okay, so that's number 10. What's next? Number 12. Yeah, sure. Number 12. Okay, let's try number 12.
Okay, I still have a question on number 10. Like,
Sure.
I didn't get it clear. How do we graph it, the graph?
Okay.
Yeah.
So first of all, let me write it. X minus 1, the quantity cubed minus 1. First of all, are you okay with this if I say we'll actually move 1 unit downwards than the original one? Are you okay with this?
Yes.
Okay. Then, if I say we'll actually go 1 unit to our right from the original graph, are you okay with this as well?
Yeah.
Okay. So now, one more thing to add here is if you multiply any particular function by a minus, it actually gives you the mirror image. So now I'll first start with the main y equals x cubed graph. Okay, so that's your y equals x cubed graph, which goes through 0, 0. Okay, so let me write for you. So as I'm multiplying by a negative, so this will be your y equals negative x cubed. Are you fine up to this?
Yes.
Okay. So now, as I said, we'll actually shift the graph from its original position. Originally it actually went through this 0, 0 point. Okay. So we'll move to its right by 1 unit and move downward by 1 unit as well. So if I first move downward, let me go downward. I'll go here. That's my negative 1. And from here, I'll also move 1 unit to my right. Here is my 1 unit to my right. So that's the point where I'll have my new graph. So let me draw it for you. let me use a different color, this one. So now my graph will actually go through this. Okay, so this is my y equals negative x minus 1, the quantity cubed minus. Instead of 0, 0, it will actually go through this point. Okay. Now does this make sense?
Yeah, I got it.
Okay, thank you. Okay,
Thank
so
you so much.
no, it's okay. Number 12. Okay, number 12. So find the difference quotient of f of x, x squared minus 4, that is fine. Oh, okay, so that's good. If the formula is given, the definition rather, the definition of difference quotient is given. So the definition, let me write it for you. F of x plus h minus f of x over h. And you need to find what happens if your function is x squared minus 4. Yeah, of course. The problems that you are told not to do, of course, it won't be on the test, of course. Yeah. I'm not that cruel, you know, that I'll say, don't do that, and then I'll give that in the test. And somehow, even on the test, if you feel one of the question was out of the syllabus, I'll definitely give you credit on that as well. That's in case, just in case I have, maybe missed 1 or 2 questions when I was setting up the question, because setting up 25 questions took me a lot of time, and of course I might have got distracted. So 1 or 2 questions might be out of the syllabus. I hope that that's not the case, but if it happens, I'll definitely give everyone a full credit. So don't worry about it. Just focus on 2.1 to 2.4. Cover all the topics I have showed. Try to understand why and how can you calculate it. Try to go deep into it. Try to understand the concept. I'm giving you 100% guarantee that you will find the exam really easy. Okay. So best of luck for that, of course. But let us quickly come back to our problem. So if f of x is the function, then this is the definition of difference of quotient. But what if the function is x squared minus? So now the difference of quotient would be, so, okay, sorry. So if f of x is x squared minus 4, what's f of x plus h? X plus h is, you are replacing your x by x plus h. So x plus h, the quantity square, minus 4, right? So in place of f of x plus h, we'll actually use this, x plus h, the quantity squared, minus 4. That straight away comes for this. And of course, we know what is our f of x. So minus x squared minus 4. I'll use parentheses so that this negative, or rather this negative sign doesn't create any problem in the first time, okay, on the first instance rather. Okay, now let's simplify it. So I'll simplify this by using the a plus b quantity squared formula. So this will be x squared 2xh plus h squared minus 4. Now I'll expand this, okay? So negative x squared, negative times x squared will be negative x squared, right? And negative times negative 4 will give us a positive 4. Are you guys okay with that? I have a negative in front, so whatever I have inside the parentheses will actually change its sign. So this positive x squared will become negative x squared. This negative 4 will become positive 4. Okay, now let's go and see if we can simplify it further. Definitely this 4 and 4 gets cancelled. This x squared and x squared gets cancelled, right? So next, we have 2xh plus h squared over h. Can we simplify it more? And the answer is, of course, yes, because we can factor out 1h from each of these terms. We can only factor out if it's present in all the terms, right? We can factor out, factorize this way if we have a particular thing in all the terms. So, I'm sorry, let me take 1h out of the first term. So if I take out this h, I'll still have a 2x plus I factored out h from this, I'll still have 1h. Okay, so that's my 2x plus h. Any question after this? Any question? How did I get that? I've just simply factorized the numerator by factoring out 1h from each term, right? And now I can clearly cancel this out. So finally, I'll have a 2x plus h. And that's your answer. Okay. Any question from this? Okay, so looks like no question from this. Okay, what's next? Which problem you want me to solve? What does the difference quotient tell us? Okay, yeah, that's a good point. So this actually says us if you just let me show this. That's your x. That's your x plus h. Okay, this is actually not this wide. This is actually h tends to 0. That means it's very, very small. This gap is actually very, very small. So this actually tells us if you just change your position by just a little bit, how does your functional value changes? How does your graph changes? Okay, so that's what it actually tells us. So for example, if I take this, if I take a really small h, it will actually tell us, as I said, it's not really not this big. It's actually smaller than this. You can actually take it really small, really, really small, and see how does your graph changes, how does your curve or curvature or rather changes. And like, when do we have to use it? Okay, so this actually, we actually use this for finding slopes. Slope is slope is actually m rise over run. So it actually gives us the idea if we run by 1 unit, how much by how much we actually go up or down. This is the basic definition for finding. So if the run h, yeah, run is h is actually basically the amount of distance you are covering. So that's run. Yeah, that's true. We'll actually not go deep into this right now because you will see this in if you somehow go to math 191, you will see that this definition is used to find derivatives. So that's something you will see there. If you take math 181 after a semester or two, we'll see that. So for now, as you can see, it actually gives us the idea what happens if we just change our position by a small distance, what it actually gives us in return. Okay, which problem is next in our hands? 18, okay. 18. Where is 18? 16, 17, 18. Okay. Find the domain. Okay, that's a very good question because I'm actually telling you the question, okay? You will see a similar question tomorrow. I'm actually disclosing the question for you. Not exactly this one, of course. Don't expect that, but yeah, we'll see a similar question tomorrow. So try to, as I said, try to have the concept completely to get it right, okay? Okay, let's try. Number 18. So our function is p of t square root of t minus 5 square root of t minus 5 over 2t minus 12. Okay, so first of all, we know that our denominator can't be 0. And for the value which makes, or rather which makes our denominator 0, we'll actually avoid that from our domain. So let's see for which value of t our denominator is being undefined. Okay, so our denominator is 2t minus 12. Set this to 0. If we solve it, t is 6, right? If we change sides for 12, it will be 2t equals 12. Then if we divide this by 2, t will be 6. So that means one thing is for sure, t can't be 6. Or rather, I'm sorry, the domain can't be 6. It could be anything else. We are not really sure as yet, but definitely one thing we know that it can't be 6. So that's a good thing. Now we know for the square root function, whatever inside the radicand, the way we say, has to be greater or equal 0, right? So let's solve that as well. So t minus 5 has to be greater or equal 0. If we solve it for t gives us greater or equal 5. Okay, now we need to combine these two to get our domain. So first of all, looks like our domain starts from 5, right? It can't be less than 5, so it will start from 5. We have a greater or equal sign here, so that means it will be closed. It will start from 5, right? How far can we go from here? Again, a +1 question for the quiz. 6. And why do you think it should be 6? Because the domain can't be 6. Exactly. So first of all, yeah, good point. So Pearson, I guess you did get 1 plus 1 yesterday as well. So it can't be +2. So again, good try. It's good for you that you are trying, but I think you already have a +1. Anyway, keep doing this. Okay, so okay, where we were? Okay, yeah. So we'll have to stop at 6, right? So, and of course, we can't really include 6, so it will be open. Okay, should we stop here? Is it the domain? And the answer is no, because we can actually go to positive infinity, because t can be anything starting from 5. It can be anything up to infinity, just apart from the 6. So that means you can again start from 6 and go to infinity. And of course, 6 will be open. Infinity is always open. And as we have more than one, we can use this. So that's your answer. Any question from this? If you don't have any question, we still have a couple of minutes. precisely 13 minutes. So I think you can still solve one or two problems. If you have anything in particular, we can do that. Otherwise, I'll pick one randomly. If you want me to solve any other question, it's the best time. Okay, 17. Okay, let's see. 17. Oh, that's a big one. I think it will take the rest of the time. Anyway, let's start. 17. I feel like a lot of the questions are repeats. Yeah, it could be. It could be. Even in the tests, you'll find questions which are quite similar. Like finding the domain, uh, finding the intercepts, and all that. That's why you might see repeat of similar questions. Yeah. Okay. 17. 17. Okay. So using the given graph of the function, find the following: the intercepts, if any, its domain, the intervals on which it's increasing, decreasing, or constant, whether it's even, odd, or neither. Oh, that's a good one though, because you actually don't need any calculation for it. You can eyeball it and write the answer straight away, right? So first of all, how many intercepts can you eyeball? Don't do anything. Don't do any calculation. Just look at the graph and eyeball it. How many times you can see it's actually going past or at least touching one or the other axis. How many times can you see that? 3, exactly. As far as I can see, at negative pi, at 0, and at pi, it's actually touching or going past x-axis, right? So clearly, our intercepts will be negative pi 0, 0, 0, and pi 0, right? Let us check the answer. Yeah, that's it. That's the answer. As you can see, it shouldn't take you more than 10 seconds. But of course, I'm not saying that you need to do this in 10 seconds. You can take your time, but don't go for explicit calculation. That might create confusion. Just look at the graph and see where, sorry, where does it take you, what's it doing, etc., etc. Try to look at this graph, okay? Okay, so that's a good one. Now, B, domain and range. That should be pretty straightforward as well. Who can tell me the domain first? Okay, I know the answer is there, but who can explain why that's the answer? You can unmute yourself if you want.
Okay, I can say as well, like it is from negative pi, the domain, to positive pi, because the graph starts from exactly from negative pi and ends at positive pi.
Very good. Yeah, that's right. That's the right answer. As you can see, the graph is not going anywhere beyond these 2 points, right? Beyond this negative pi and pi. It starts from negative pi and stops exactly at pi. So that should be your domain. So negative pi to pi. It's not a continuous function. Okay. So you need to take care of that. Okay. Now, again, I know the range is written, but why is that? Why? That's the answer. Someone else? Daniel, thank you for that. Can anyone else try that? Yeah,
because the curve does not go above 9 or below -9.
Exactly.
So,
again, we can eyeball it. The graph hasn't gone beyond that point 9 or below that point -9, right? So again, our answer is -9 to 9, closed, right? Because that's defined. That is also included. Oh, sorry. I think the pi is also included. Sorry. I was on a flow, so I missed it out. I apologize for that. It should be closed as well because pi and negative pi is also included, right? Okay. Next, find the intervals on which it's increasing, decreasing, or constant. Okay, again, you can actually eyeball it. So can anyone tell me the interval? You can write it in the chat section now. Can anyone tell me the interval where it's increasing? Be careful. Don't look at the answer, as I say. Don't look at the answer. Try yourself first, then check whether your work is right or not. Excuse me. Okay, so I have one answer from 0 to pi. The function is increasing. Anyone else? Yeah, now the answer is right. As you can see, let me draw the graph for you real quick. As you can see, on this portion, the function is on the rise, right? So definitely from negative pi over 2 to pi over 2, the function is increasing, okay? Right? Okay, similarly, we can see the interval where it's decreasing as well. It's definitely decreasing here. It's definitely decreasing here. Excuse me. So I think it's negative pi. It's negative pi over 2, 0, pi over 2, and pi. So looks like from negative pi to pi over 2, negative pi to pi over 2, and from pi over 2 to pi, right? So these are the intervals where our function is decreasing, okay? And of course, as it covers the entire region, that means we can actually see that, although, but yeah, even from the intervals, we can say there is no place where it's constant, right? Okay, the last one, whether it's even, odd, or neither. So again, I know the answer is given, but who can explain why that's the answer? You can unmute yourself. Try someone apart from Pearson and Daniel. Anyone else can try. You can unmute yourself and explain why is that odd. It's been said it's odd, but why is that? Anyone? Give it a shot. Okay, Barbara, because it's symmetric to the origin. Exactly, yeah. If you remember, for odd function, we said we'll have a similar looking portion in either side of the origin, right? That as we can bisect it at the origin, we can see this guy and this guy looks pretty similar, right? So that is obviously out. Okay, so that's it for 17. I still have a couple of minutes, so any chance we could do 21 really quick? Yeah, let us give it a try. 21. Where is that? Okay, 21. Yeah, I think we have more than enough time to finish that. That's a good choice. Yes, son. 21, g of x, 2x squared plus 7. Yeah. Okay, so the question is whether it's odd, even, or neither. So if you have a graph, we can see whether it's symmetric with respect to the origin or the y-axis. And if we have a function given, then we can actually replace the x by negative x. So we'll actually replace it by a negative x to negative, negative x squared plus 7, okay? Negative x squared will be still x squared plus 7. This is exactly the same thing as g of x. So we are getting even though we have replaced x by negative x, we are getting the same result. It's even. As you can see, it didn't take more than 30 seconds. It's actually less than that, right? But for your test, take your time, do it, with full concentration, because this often could be tricky. If you just miss this negative here and there, your answer could be wrong. Okay, so keep an eye on that. Okay, I have still 2 minutes. Any other questions? Any other concerns? When will 2.5 be posted? Yeah. I think it will be visible from 4 p.m. or rather, sorry, from 6 p.m. tonight. And or it could be visible already. I'm not sure. I've actually assigned that and assigned the time from when it will be available. I've actually assigned that yesterday. So probably within an hour, you will be able to see that. And of course, you'll have 2 days to complete that. Whenever I assign one homework, you'll have 2 days. I wish it is visible. Yeah, right. As I said, I actually assigned it yesterday and set the time of time when it will be shown on your mind as that. So, excuse me. So I wish I could give you more time, but as you can see, it's a small semester and we need to do lots of stuff. So I think 2 days should be an ideal deadline. And okay, so that's it. Tomorrow we don't have any live class, but don't forget to go for the test between 8 a.m. to 8 p.m. You need to finish that in one sitting. Don't leave that in between, okay? Complete that in one sitting. You'll have a 45 minutes window, which I think is more than enough for that 25 questions. As you can see, no question should, most of the questions will actually take less than a minute. So I think you'll have a more than enough time. So keep patience, have full concentration on the signs and all that. Take a look at the question very carefully. Try to understand what the question wants you to do, okay? And yeah, best of luck for tomorrow. And don't forget to appear for the quiz as well, just before the class. It will be available from 3 to 3:15. Once again, you need to finish that on one sitting, and you will have a 10 minutes window for that as well. It will be only on 2.5, okay? Okay, so I'll see you guys on Monday. Well, as I said, it's available from 3 to 3:15. So of course, you need to finish that within that time. You can't really do anything after 3:15, and then our class starts at 3:15. So of course, you need to finish it before the class. Yeah. Okay, so I'm stopping this recording, and I'll be sending you the file. Yeah, sure, I'll actually do that. Of course, I know some of you might get carried away, so of course I'll send you a reminder about the quiz. Yeah. Okay, see you on Monday. Bye-bye.